In this video, we're going to learn how to draw Lewis structures, otherwise known as electron-dot structures. Now, being able to draw a Lewis structure is important because it helps us to determine the shape of the molecule, which then in turn helps us to determine whether it is polar or nonpolar. And both the shape of the molecule and the polarity help us to determine its solubility as well as how it reacts. And so drawing Lewis structures is one of the basic building blocks of chemistry, and it's important to be able to do that. Here are some steps for drawing Lewis structures. We'll go through these and then we'll look at some examples. So first off, we're going to want to determine the total number of valence electrons from all of the atoms that are in the molecule. And we'll do that by looking at their place, the atoms, where they're located on the periodic table. And then number 2, determine the arrangements of atoms, so how they're bonded together. Number 3, we'll add the bonds to that. And remember, a single bond is a pair of electrons or 2 electrons. And then once we get all of the bonds in place, we'll subtract out the number of bonding electrons from that total valence electrons that we determined in step 1. And the remaining electrons that we have, we'll add those in pairs around the atoms to complete their octets. Now, if we run out of electrons to complete octets, we can move non-bonding pairs of electrons to form double or even triple bonds if necessary. So let's go ahead and look at an example. We'll start with water. Water has a formula of H2O, so 2 hydrogen atoms bonding to 1 oxygen atom. Hydrogen is in group 1A, and so if we go down for step 1, where we are determining the total number of valence electrons, each hydrogen atom has 1 valence electron, so it's in group 1A, so we have 2 valence electrons from the hydrogens, since we have 2 hydrogen atoms. We have 1 oxygen atom, it's in group 6A, and so it has 6 valence electrons. So 2 plus 2 gives us a total of 8 electrons for this molecule. And that's step 1. Step 2, determine the arrangement of atoms. So oxygen is going to be our central atom, and we'll have hydrogen bonding to it. So I'll draw it like that. Step 3 are to add the bond. So I'm going to draw a pair there between the oxygen and hydrogen on both sides. So that takes care of 4 electrons, so I can subtract out 4 electrons, and that gives me 4 electrons left to place around the oxygen, because hydrogen, remember, it just has just 1 electron shell, so it can only hold 2 electrons, so it's happy with 2 around it. Draw 2 dots, 2 pairs around the oxygen atom, and so that gives oxygen 8 electrons around it, or its octet, and so that would be the completed Lewis structure for water. Let's look at a couple more examples. The first one we're going to look at is nitrogen tribromide. And so we'll start with number 1, to determine the total number of valence electrons. Nitrogen is in group 5A, so it has 5 valence electrons. Bromine is in group 7A, so there are 7. For each bromine, there are 3 in the molecule, so we'll multiply 3 times 7 to give us 21 valence electrons, plus the 5 from nitrogen gives us a total of 26 electrons. Step 2 is to determine the arrangement of atoms. And so in this case, nitrogen is our central atom. Bromine is going to be written around that on 3 of the sides. Okay, step 3 is to add the bonds in between there. I'm going to put a pair of electrons between the nitrogen, each of the bromines. That takes care of 6 electrons. So I'll subtract that from the total number we had. That leaves us with 20 electrons to place around each atom to get their octet. I will just start by adding pairs around each of them. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that takes care of all of the electrons, and there are 8 electrons around each of those atoms since the electron pairs that form the bonds count towards both atom and that bond's octet. And so that is the completed electron dot structure for nitrogen tribromide. Let's look at one last example. We're going to look at this one, H2CO. So we'll start out by determining the total number of valence electrons. There are 2 hydrogens. Each hydrogen has 1 valence electron. So we get 2 valence electrons from the hydrogens. Carbon is in group 4A. It has 4 valence electrons. Oxygen is in 6A. It has 6 valence electrons. So 2 plus 4 plus 6 gives us a total of 12 electrons to place. In this molecule, carbon is going to be our central atom. Oxygen, I'll put here, and hydrogen on each side. Okay, so step 3 is to add the bonds to it. And so I'll place a bond between the carbon and hydrogen, between the oxygen and carbon, and over here between carbon and hydrogen. That takes care of 6 bonds, or 6 electrons, I'm sorry. So we have 6 electrons left. Hydrogens do not need any more. They're happy with 2. That's their octet. So I'll put 2 down here around carbon, 4, 6. Okay, I have run out of electrons. Carbon has an octet, but oxygen does not. So if you get to this point, what we're going to do is move a non-bonding pair. What I mean by non-bonding is that this pair of electrons underneath carbon is not involved in a bond. So I'm moving that non-bonding pair up here to form a double bond. So I will rewrite that. And so instead of having just a single pair between the carbon and oxygen, I'm going to have 2 pairs between carbon and oxygen, and that forms a double bond. And then I also have my 2 pairs of non-bonding electrons around the oxygen. So if we count up the electrons, we still have just 12. But now, because that double bond counts towards both the oxygen and carbon's octet, both oxygen and carbon have 8 electrons around it. So that would be the Lewis structure, electron dot structure for it. Now, another way to write this, or that you will see often, is with lines representing the bonds. So this might be how you might see that drawn, where each line, each bond, represents a pair of electrons, or 2 electrons. So keep that in mind when you see those structures in your book or notes or other places. So this just goes through the steps for how to draw Lewis structures or electron dot structures for some simple molecules.